Hi all. So today we have kind of gathered for restarting the graph database chapter here for new 4G Pune. Okay. So we are going to start with the fundamentals of new 4G. I know that many of us are very new to the new 4G itself. So I plan to start with the formal discussion and then see uh, just have a get to know what all components are there with the new 4G, and we'll continue from there. Maybe based on your inputs, we'll plan out the upcoming events as well. Okay, right. So just give me a second. Yeah, I'm not seeing those pointers. Let me see. Allow me a minute. No? One second. Right. Okay. So you might have been seeing my screen. The next slide. So a quick introduction to the new 4G. As you know, it's a graph database. Okay, and when we say graph, you will always find that there will be some nodes in a graph, and there will be a connection between two nodes. Let's say, okay, I will discuss that with the help of maybe a graph, or I mean a picture itself. Okay, how that looks like. So when we talk about Neo4j, it's a graph database which stores all of your data, which we generally used to save in a table in the form of nodes. Okay, and there will be connections between two nodes. Okay, two or more nodes. They can be connected with multiple ways, and there are properties based on those nodes that are there, right? And it is designed based on the data that we are, like nowadays if you see, we have more of the data related to let's say social media platforms. You will have mutual connections that we want to represent, right? So that is easier when we use a graph instead of any transactional databases, or let's say structured database that we in general use, right? Also, why we want to learn Neo4j? Obviously, it offers a better data modeling if you compare it with the real world problems where we are really looking for uh, not only for I mean performing the transactional data, but also you might have heard of the term NoSQL. In NoSQL also, we try to represent data in a very unstructured form, but there are challenges that if you want to represent some of the values or the properties in a very optimized way, that is very challenging when you try to scale. So in a very small size of databases, it was possible, but as you scale it to the multiples, let's say that millions or record, then it becomes challenging, right? Because you have to keep repeating multiple properties, you can say. Okay, and that's where we kind of got to the graph databases to represent those in better I mean better way. Yeah, right. Now, so new 4G is a graph database, but what is graph database itself, right? So if you see, as I go by the definition, a graph database uses the graph structures, okay, where you will see that if you see my cursor moving, so at the center of it, you see there is a node, okay, so maybe you can say a central node, which is connected to multiple other nodes, okay. Now those multiple nodes are connected with something, right? Now, here you see this is my central node, and if I say like there is no connection with this node, then that becomes a edge. Okay, to connect that, there are connections between it, right? Which is nothing but your relationships. If I talk it from the graph database perspective, okay. Now those connections or the relationship that we are seeing here, they are represented in the form of, you can say, a key value of pairs. I mean the properties what is assigned to it, that will be a key value pair, and that makes it easier for us to establish those connections and even extend it to the multiple layers. And there are other properties that we'll look into when I go further slides. Okay, now just take this. This is very simplistic way to explain the graph database altogether. Okay, now let's see this diagram. So if you see, there are four nodes, right? And the nodes are nothing but they are, let's say, it can be a noun, right? So it's a place, it's a name, it's a I mean, it's a thing. So it's a company, you say. Okay. Now, if you see here, so we have Michael, okay, and Sarah. Okay, so these are two persons. They are probably working for company Neo4j. Now, where Neo4j is founded, that is in Sweden, right? So now if I want to represent this in the form of table, you see, I have to create multiple columns to identify, I mean, let's say that one could be company as one of the column, then location another column, person is another column. But when I have the person, I will be writing Michael and Sarah as a person. But what Michael is doing, he's also an employee. So I have to add one more column there, right? Which makes it like difficult if you really grow your data, like when it is going to scale to a higher side of it. Okay, so here what we are trying to do is I will be creating a label for these nodes. So when I have a label saying that Michael as one of the I mean, if I say when I have a node which is Michael, okay, now that will be assigned two labels. One is person, another one is employee, right? Similarly, for Sarah, as of now, we have assigned only one label, that is person. Okay. Now, what is the relationship between Michael and Sarah? If I want to represent that, for that I'll be using the relationship here, which is nothing but the married to. So that is nothing but a you can say at birth, right? So that's how we are trying to establish a connection between them. So this can be like a unidirectional or the bidirectional kind of relationship that we are able to showcase here. Okay. Now similarly, now what Michael does that if I want to establish a connection between Neo4j, that is a company, and Michael, that again I am creating another relationship here, a unidirectional relationship, which is like a he works at, right? So that's a, I mean relationships property, which is like you can say he works at, and the property is what he is having a position as engineer. So this position as engineer is also a property here. Okay, so there can be properties of the node and the relationship. Okay, now so if I talk about the relationship, that has a property what key value pair property, which is position equals to engineer. Okay, when I talk about Michael, then he has the properties his first name, last name, when he was born, right? So all that is easy to represent when I am using a graph. Okay, so there are like a basic architecture to it, like how that is saved and all. Okay, but this is how we represent any information in a graph. Okay, this is how it looks like in a very simplistic way, if you see. Now, so something more about why these graph databases, what are the benefits that we are getting? So if I talk about the benefits, graph databases excel at representing the complex relationship between the data. So here if you see this, like four nodes structure itself is very kind of, if you see, kind of complex, right? Now imagine if we scale it to millions of records and we try to represent all of that. Okay, so that becomes very difficult or very complex to actually figure out what uh, I mean what the relationship has with what, right? So if that is presented in a table, it's very difficult to even figure out those connections, and I have to be very deep into the SQL and all those concepts, right? But here it's very easy to represent. I can easily figure out who is having what connection. So that complexity is being taken out when we are talking about the graph databases. Okay, and they are really working in very real time query performance also, right? So and there is a flexibility of the schema, so it's, you can say it's a kind of a schema less design also. So here we are not worried about what sort of schema would be here for showcasing any of these relations. So if I say the Sarah and Michael, they have the relationship as married to, right? But now, if I go to the next layer where Michael is working for Neo4j, I'm just presenting only one kind of relationship. The schema is not very rigid. So I can have any sort of schema for whenever I'm extending my relationship with the next node. Okay. What are the use cases? That's mostly on the social networking, even for the fraud detection. So one of the use cases that I'm really currently invested in, like where I'm involved with, that is more on the fraud detection part. Okay, and there are like the recommendation engine also is what I'm currently working with also. Okay, now it is also can be used for the supply chain optimization where you have a lot of connections in place, right? So you will have a producer, then distributor, then the delivery partners or the customers, right? So those are multiple connections. So that is where the graph database is really making more sense. Now let's go into the knowledge graphs. So in the knowledge graph, what it is nothing but just the graph database itself. Okay, but the information that we normally have, like let's say that you are involved with multiple components. So let's say that Neo4j is a company. Okay, now I want to store all the information regarding company Neo4j in a graphical representation, which makes me easy to actually traverse through it and then easily get all those informations, right? So out of that, a knowledge graph is created. So in the knowledge graph, if you see, what I have is at the center of the node, I have Neo4j, which is a company, okay, having a level company. I want to get all the information about Neo4j. So let's say that what is it about? So I'll have the blog post articles about the Neo4j where I can get more information about Neo4j itself, where it is located, who founded it. That I can actually find out again. Like Malmo location is in Sweden somewhere, right? So if you also see here, there are multiple relationship from one node to the other node. So we can, so this sort of schema less structure when I was talking, what you see, I can have even representation of multiple relationship with two entities, I mean two nodes, which is giving me more flexibility to represent this data. Okay. Then where it is located, the location, London, capital of UK, like that. Okay. So all this when I am able to use to even create a knowledge graph where it takes, can you think of it? So it really it really matters nowadays, just because what is the term that we are hearing nowadays actually a lot, which is nothing but the generative AI, right? Now in generative AI, if I go into the next slide, in generative AI, we are really making use of these knowledge graphs. Okay, this is very much helpful nowadays. So when we are having our own knowledge graphs, okay, which is created out of these graph databases, obviously in place of knowledge graphs, you could have something different also. Let's say that you will have some other RAG models. This is again a RAG approach where you have the retrieval augmented generation, where what we are doing is we are providing our own data to the Gen AI applications, and it is relying completely on these knowledge graphs or knowledge database to give me the responses, which is going to be more accurate, right? So I'm just trying to make a good establishment between how the knowledge graph and the today's generative AI approach is improved with the help of that. And that is where we are also seeing the the more talk of the new 4G as such as a graph database. Okay, because that reduces the complexity that we have altogether with the databases. And then when it is plugged in with the generative AI applications where we really need to have very fast performance, we need to have very optimized solutioning, that is where it makes more sense. So now when we have the, whenever let's say that you have an enterprise application which is like going to be used for generating any responses by the user, So if you see what is happening here, you have an enterprise application which is provided a prompt. Okay, now that prompt is really passed on through the, I'm going to backward direction also. If you see, so if I see it like a user, he is going to uh, ask any questions to your enterprise application with the help of prompts. Okay, now that prompt is obviously going to call LLM API, okay, to get any responses. Now that response that is generated here, that is actually coming from this knowledge graph itself. Okay, so it is retrieving the information from the knowledge graph and responding back to the user with high accuracy. Like the accuracy could be even 900, 90% plus. Okay, just because now instead of getting the data, a random data generated from this generative application, you are relying on the uh, graph database. Okay, right. Now, coming to the new 4G architecture, if I see, so there are basically four components. I'm just trying to highlight very high level. It's going to be very deep dive in the upcoming sessions, I would say. Okay, so new 4G architecture, if you see, there is a query engine behind. Okay, so if you think about like how the data is being stored and how we retrieve it, so it is nothing but a cipher. Cipher is, you can say, a query language, okay, similar to SQL. So it retrieves the query from graphs. So that's why it's a graph query language, okay, which is optimized for querying the graph data with a high efficiency, right? Also, for storing any information, it is using the graph storage. Okay, so that's where the storage part is coming, and the indexing is performed, but this indexing is definitely different than what you do with the traditional, you can say, structured databases. So in case of Neo 4G, it's actually using pointers for identifying or in easy indexing of the information here. Okay, which makes it very easy to retrieve any of the information quickly. Then deployment. So Neo 4G can be deployed as a single instance. Like you can have a, install it. Let's say you can install in a Kubernetes or maybe a VM, or you can install as a like a cluster way. So you see, either I can have it in a VM, a virtual machine, or even on your system. Okay, or you can install it as a Kubernetes solution with, as a clustering, right? So which makes it more scalable and highly available. So these two versions, and even now Neo 4G has their own web version of it, like you say, the AuraDB. Okay, right. So coming to the use cases, there are a few use cases that I have like very high level highlighted that. So it can be used for the finances, retail, healthcare, logistics. So if I talk about the finances, uh, it is used for the fraud detection, as I have spoke about earlier. Okay, and it builds a comprehensive view of the customer across different data sources. In the retail, if you see, it is more helpful for the recommendation engines that we build. So let's take an example of e-commerce platform, Amazon. So you buy something and then it will show you, okay, you can, people also buy similar products like that, right? Or it will show you the details of, okay, previously you also bought this, or there will be a way to provide you better recommendations based on your past purchases or what you are really looking for. Okay, which having the kind of percentage of similarities, how much they are able to identify. Then for the healthcare, if you see, it can be used for analyzing the drug interactions. Like um, if someone is from the healthcare industry, they will understand it better. So it will help us to identify what chemical will suit better for the disease in hand, like some disease that I am currently having, and I want to uh, go with the drug discovery kind of approach, and I'll be able to identify that with the help of these graphs. I mean, they are really very useful, I would say, for the graph technology. Also for the logistics, as I said, this is more from the supply chain side of it. where it helps in analyzing your relationship between the supplier, products, delivery routes, the payments that is done, right? What inventory is in having as of now, right? So all those. Okay. Right. So we are at the end of this presentation, I would say. So here I have tried to highlight some of the resources which is going to be useful going forward. Like this is very beginning of the this chapter again in Pune. Okay, but I just want to highlight some of the resources that will be very useful once you are done with this session and going forward, if you find it very useful for yourself, right? So this is the link for the Pune graph database community, where you identify that and get connected with the upcoming sessions. Also, you can join the online community, Neo 4G community, where if you have any queries with related to Neo 4G, where you are not able to find the right kind of uh, answers for it. Okay. Apart from that, some resources where you should be using it, like a Neo 4G developer portal, the documentations, Graph Academy, where you can actually learn about everything about the Neo 4G, like having the free sources about it, and the YouTube channel itself for the new 4G, right? So these are all the resources that should be really looking at if you want to learn new 4G better. Yeah, right. So that's all about this session. Yeah, yes, Ankit, you have some questions. I think yeah, yeah, Ravindra, go ahead.
So I have one question like, so in this like database, Neo 4J, so even this in this case also we need to write a schema, like you need to
No,
describe
you
the
don't.
employee, company, and all these things.
No, you don't have to write a schema, but the representation is different. It's like you are creating, you can say, properties you are creating, labels you are creating. Okay, so it's not a schema actually, you can say.
So basically, what we are inputting the NeoDB, like
Right.
we are.
We are providing the key value pairs, like if you have worked with the document databases, right? So you will have the properties where you provide a key value pair. Let's say that what is the name, so first name, last name, like that, right? So those properties will be there. There will be the nodes which is presented as, let's say that the nouns itself, right? So a name, place, look, thing, right? So it's a very much you can say a real world scenario, uh, and how the connections are built between multiple people. So you just uh, look it from that perspective. So how the world works, right? So let's say that you are now today this session is happening, right? So like me, I can be one person, you are another person. We are connected through this Pune chapter, so that's kind of relationship it shows, right? So
Mhm.
yeah, so those sort of details you are saving, and the representation is like there is a cipher query language, that is how you can store this information. So similar to how SQL works, there is a cipher language here. That's how you save it.
Okay, so let's say in this example which you gave me that you are the speaker, so you
Mhm.
are even entity as a speaker or
Correct. Yeah.
instance of that particular entity, or I am the
Yeah.
listener.
Yes. So
So do I need to define a speaker and listener in this database?
yes, yes, you have to. So that's a relationship, right? So that's
Yes.
how it's showing it. So yeah, you have to define that, but it's not a hard definition. That's what I'm saying. So that schema is not like kind of rigid that you have to have it predefined and then only you can work on it. Not like that. So you have the flexibility. It's that's where it says said as a schema-less kind of architecture for graph databases.
If I want to, let's say, import or export or give this database to somebody,
Mhm.
then I need to provide this schema or this understanding.
So
So,
that's where you have the cipher query language, right?
okay.
So that will help you retrieve any information from here. Obviously, you have to learn a new technology altogether for the graph database. but that's how it works. See, the picture came in place for graph databases just because it's very complex when you want to represent multiple relationship, multiple piece of work that, I mean, those connections you want to represent better. Okay, basically for the use cases that I talked about. So if we have such use cases in that, it it is not going to be a good fit for the structured databases where you create tables and then try to showcase that. Then you have the dependency with the foreign keys and all, and if that is not managed well, then your database is not going to work anyway. So that is not the case in this scenario. So
Okay.
we'll go deeper into upcoming sessions if you want to know it better, right? So
Do we have like visualization utility with this new DP
yes.
application?
Yeah, yeah,
Okay.
yeah. We have the visualization added with it. Yeah,
Okay. Okay. Thanks. Thanks,
yeah,
Jiten.
sure, no problem. Hi, Sumit. Sumit, Akshay, do you have any questions?
Hello.
Yeah,
Uh,
Akshay.
are you able to hear me?
Yes.
Yeah, yeah. I have the same question. There is the new 4J is the only database which based on graphs, or there are others which based on.
There are others. There are others. I don't have the names upfront as of with me, but
That
there
is
are.
the example. Sorry for interrupt, Jitendra.
Sorry.
Tiger Graph is the another major player for related with
Right,
the
right,
your graph database. But
right.
yeah,
And the
sorry,
syntax of the cipher language will be the same.
No, they are different. So, I mean, if we talk about the
they are
cipher,
different
the implementation
based
is
on the
different.
different. And another is if you
Okay, so
know the company Altair. Altair is another example. They are
mhm.
Yeah,
using, they are providing the graph database solution. But yeah, but most of the market and in fact the main uh, enterprise companies, they are mostly tie up with the Neo4j in terms of database.
correct, correct.
I mean graph database.
Yeah. So I
Okay,
can
so
see that
but
you.
there are many tools available in which, for example, if you work on one graph database, one cipher language, and you want to convert it into the same query in the other database, so there may be a tool available.
Right, right.
Okay, okay, that's it. Thank you.
Sure, no problem.
Thank you, Saurav, also.
Yeah. So these are the companies. If you see, they
Mm,
are
No,
advertising.
no problem, Sumit. And this is the initial call, this is the just like intro call we are doing this time. And most of the cases we are going to be for next month, maybe the probably next to next month, we are also planning to have a communication with everyone who is much interested with the graph database. So let's wait for next communication from Mayur Rathi.